All right, so we're going to continue talking about equations, but today it's going to be a little bit different. We're going to take a look at what are called literal equations, which are basically formulas. Formulas are a type of literal equation where they're going to have multiple variables in them, and how to go about solving for those particular variables. Good news is we're going to use the exact same steps as solving an equation, so it should not be a big deal. Some vocabulary for you. A literal equation is an equation that involves two or more variables, right? So now instead of just having an x in there or a y to solve for, we're going to have a couple of variables. A formula, again, is a particular type of literal equation. It's an equation that states a relationship among quantities, right? You know some formulas already. That's the area of a rectangle. So there's a relationship between the length and the width there in terms of the area. So that's what we're talking about. So formulas, again, are special types of literal equations. Sometimes the formulas use the same variable, so you do have to be kind of careful about what the variables stand for. So for example, in this formula here, the C stands for circumference, and that's for a circle, right? Whereas here, the C stands for Celsius in terms of temperature, degrees. So again, make sure that you understand what the variables stand for, and that'll help you decide sometimes what variable you need to solve for. All right, some very common formulas are listed here. I think you do need to fill these in your notes, so feel free to pause the video and write those all in if you need to, and then start the video back up. But you've got your perimeter of a rectangle, circumference of a circle, the area of a rectangle and a triangle, the area of a circle, the distance formula in terms of motion problems, distance equals rate times time, and then your temperature formula that you saw just a second ago. So those are some of the formulas that we'll work with, and we'll talk about solving for one of those particular variables in there. Sometimes you're going to want to do that. Okay, that's what we're going to get into now. Solving a literal equation is the same as solving just a regular algebraic equation, right? You're going to figure out which variable you want to isolate. It's just going to be one of them. And then we go through our steps. We undo addition and subtraction first. And then we undo multiplication and division to try to get that variable by itself with a coefficient of 1, right? So let's check it out. Here's a literal equation that you should recognize, right? You have worked with these equations before. This is a linear literal equation. That's what you use to graph lines, right? And what you've done in the past is you've solved for y, right? So we've got two variables in here, and we want to get this y by itself. Well, just like trying to solve for a variable before, right? Since this term has the y in it, we need to undo addition and subtraction around that term first. Since we're adding the 4x to it, we want to take that away. So we want to subtract 4x from both sides. Right? 4x minus 4x is 0. That's the whole point in subtracting 4x from both sides, and that leaves us with 2y on the left-hand side. Now, you've got to be careful here. 8 and negative 4x, those are not like terms. You cannot combine those two. Okay? So what we do is we just bring down the variable term first, and then bring down the constant. So negative 4x plus 8. Okay? Do not try to combine those and make that 4x. It's not. It's negative 4x plus 8. You can't put them together. One's got an x, one does not. So from here, now you go back. We're trying to isolate that y, right? So now we have to undo this multiplication by dividing everything through by 2. And when you do, you get negative 4 over 2. You divide that, you get negative 2x. 8 divided by 2 is 4, and we're done. We've now solved this literal equation for y. Okay? And that's all there is to it. Again, I know you've done this in the past. You just got to sort of refresh your memory a little bit, right? Number 2, you're going to solve for y. Go ahead, stop the video, give it a shot, and then you can start it back up. We'll walk through it real quick. Okay? So, again, here's the y. This is the term that has the y in it. So we need to undo this negative 5x first. We've got to undo stuff around it first. Negative 5x plus 5x is 0, leaving us with 6y equals, again, you cannot combine 30 and 5x. So just bring down the 5x and the 30. And then we have to undo the multiplication here. We have to divide by 6. And now the 5 and the 6 won't divide, so we'll just leave it 5/6 x. 30 divided by 6 is 5. And now we're done. Okay? That's all you got to do. All right. Try 3. Stop the video. I'll have it worked out when you start it back up. And just make sure that you're right. Did you get this? Oh, you got to be careful. Number 3 said you wanted to solve for x this time, right? So this is the term with the x in it. That's what you need to undo any addition around that term right now, which means you had to subtract 2y from both sides. You weren't getting y by itself this time. You were getting x by itself. So you subtract the 2y and then divide through by negative 4, and you get the equation with x by itself and not y. Okay? And sometimes we need to do that. Sometimes we want to be able to solve for different variables in different literal equations. So you got to be really careful about which variable you're trying to solve for. Okay? Go ahead and try 4. Again, you're solving for x, so be careful of that. Give it a shot. Stop the video, start it back up, and see if you're right. Did you get x equals negative 3y minus 6? Okay, and those are the steps there that you need to take. If you didn't, make sure that you are coming in and asking questions during STAR. Okay? All right, number 5 is going to be kind of the same, only we're going to take the x and the y out. Now we're not talking about a linear equation necessarily. I mean, we are, but not the linear equations that you're used to seeing. But it's still the same thing. We're going to solve for p, right? So identify the term that has p in it. Okay? And then we need to undo the addition around that term, so subtract 2m from both sides. You get 6p equals negative 2m minus 2. Okay? Then divide through by 6. All right? 2 over 6 is 1/3. Do not make this 3m and, do not make this negative 3m and negative 3. You reduce those into fractions, 1/3. Okay, so be careful about that. And there you go. Right? It shouldn't matter. It shouldn't matter what variables we have in the equation. It shouldn't matter what variable you solve for. Identify the variable you have to solve for, w. Put a box around that term, and then undo the terms around it, right? We want to get rid of this negative 3r by adding 3r to both sides. That gives you 0. We get negative 2w equals, again, you cannot combine the 6 and the 3r and get 9r. You just bring down the 3r and the plus 6, and you leave them side by side. And then you divide everything through by negative 2. Watch your signs. Negative 3 halves r, and then 6 divided by negative 2 is negative 3. Watch those. Okay? All right. Now, number 7 introduces a third variable in a formula or a literal equation. But that's okay, right? As long as you remember that you can only combine like terms, then it shouldn't matter how many variables are in there. It's the same process. We want to take this perimeter formula for a rectangle, and we want to solve for w. So I underline the w, I put a box around that term, and I realize, okay, then I need to get rid of that 2l. So I'm going to subtract 2l here and subtract 2l here. That gives me 0. 2l minus 2l is 0. That's the whole point. So we get 2w equals, and then the p and the negative 2l are not like terms. They have different variables. So just write them down. P minus 2l. Now, for the w, we've got to divide by 2 to get it by itself. So we just divide everything by 2. And we get w equals. P over 2 just stays p over 2. Now, the 2's here will divide out. So you get minus l. And that's what the perimeter formula for a rectangle would look like if you wanted to get w by itself. Okay? Now you try it. Well, this says solve for P. That's a little bit weird. It's already solved for P, right? So I'm guessing this was supposed to be solved for L. Right? So give it a shot, stop the video, solve for L, start it back up, and make sure you're right. Did you get P over 2 minus W equals L? It should look a lot like the last one did, only the L and the W are switched, right? The steps are the same. So there you go, right? All right, now here's things get a little bit tricky if you're not careful. And remember, we're undoing the operations that are happening to our variable that we want to solve for. So this particular formula, circumference formula of a circle, C equals 2 pi r. Maybe I need to get r by itself to make the arithmetic a little bit easier when I know other information. So I'm still going to underline the 2r. I'm going to put a box around that entire term that has the r in it. And then I would look to see if there's any addition or subtraction out here to get rid of. And there's not, so I skip that step. Instead, I look, and now I want to get rid of multiplication or division. To this r, we're multiplying by this 2 and this pi. So I've got to divide by 2 and divide by pi. Well, I can go ahead and do that right now. I can divide by 2 and I can divide by pi, and I got to do that to both sides of the equation. These both are going to divide out to 1, which leaves me with 1r, which is what I want. And these guys, we can't divide them out. There's nothing for us to do. So we just write down c over 2 pi, and we're done. That's it. We're done with that. Okay? Don't try to do more than that because you feel like there needs to be an extra step or two. Right? Just leave it like that. We're done. Okay? This guy looks a little bit weird because of the fraction, right? Let's see if we can't link what we did in the last class, which was solving equations with fractions in it, with this guy right here, right? We want everybody to have a denominator of 2. Right now, this whole term has a denominator of 2. It's right there. The b and the h are like the x pulled down to the side. We don't worry about those guys so much because their denominator is already 2 because that 2 is there. This a has a denominator of 1, though, and that a needs to have a common denominator. So get a denominator for all your fractions, and then we can drop the denominator. So we got to multiply 2 here and 2 here, and I get 2a over 2 equals 1/2. B and the h are with that 1/2. Now drop them. So 2a equals bh. And since we're solving for b, we have to divide the h. We have to get rid of the h. So we get 2a over h equals b, and we are done because we can't combine the a and the h. Okay, that's simple. So get your common denominators, drop the denominators, and then solve for whatever variable you're left needing to solve for. All right? This guy, try to solve for h. Go ahead and give that a shot. Stop the video, start it back up, see if you're right. Did you get 2a over b equals h? It's a lot like the last problem, only the h and the b are switched. So, again, and why would we do this? Well, you know, sometimes for a triangle, this is the area formula for a triangle. Sometimes we already know the area and we know the base length of the triangle, and we just want to find the height. So we can go ahead and use this simplified, and this is easier. This should be easier than solving an equation with one variable in it because there's less stuff that we can do. We just kind of put stuff together and that's it, right? So we use this to get the h by itself and then plug in our numbers and do the arithmetic. It makes our math a little bit easier. That's why we're doing this. Okay? All right, a couple more here. Solve for r. Use what we've talked about and try to give that a shot. Stop the video. Start it back up and see if you're right. That was literally all you needed to do. Divide both sides by t, and r ends up being d over t. The rate is distance over time. Okay? It's not a lot different for 13. I'd have you do it, but you should be pros at this by now. Divide both sides by r because we're trying to get t by itself, and we get d over r, and that is it. That's literally all you got to do. Okay? All right. So, like I said, why are we solving these literal equations and formulas for a variable? Because it does actually make our arithmetic a little bit easier. Here, if we can take this formula, this literal equation, and solve for m, then we can plug in what we have for n, what we know n can be, and we can find out what m is. So in other words, m is here. I want to put a box around that term, get rid of this 3n. That adds to 0, so you get m equals negative 3n plus 7. Now, if n is negative 2, we want to find out what m is. So we're going to do this 3 times. So we get 6 plus 7, which is 13. So m is going to be 13. Or when we plug in 0, we get 0 plus 7, or 7, so it's going to be 7. Or we're going to do this a third time and plug in 1. Negative 3 times 1 is negative 3. Negative 3 plus 7 is 4. So when n is negative 2, m is 13. When it's 0, m is 7. When it's 1, m is 4. Okay? So that's what these problems are all about here. So solve this equation for n, right? Oh, wait. No, it says solve for m again. So solve for m. Plug in the n values and find out what m is when the n takes those different values. Okay? Stop the video, start it back up, and see if you're right. Okay, so your formula should be n equals 4n minus 4. Right? So now we're going to take this equation and 3 times. We're going to plug in something different for n. So 4 times negative 5 first. We get negative 20 minus 4. Then we take 4 times 1 minus 4, which is 4 minus 4, which is 0. And then we take 4 times 3 minus 4, which is 12 minus 4, which is 8. So the 3 values of m are negative 24, 0, and 8. Okay, and it's just that simple. All right, one more here for you. Solve for m, plug in values of n. You can stop the video, do the entire problem, and then start it back up, and you'll see the solution. And there you go. The formula that you should come up with was m equals 2/3 n plus 1/3. And then you can see all the work, plug it in, negative 3, 0, and 3 for n, right? If that doesn't make sense, if you don't know where this stuff is coming from, then come in during STAR, let's sit down and let's go over it, okay? But that's it. Homework sitting out in Canvas. Have that done by next time.